Assalamualaikum everyone, I hope you are doing great. In this video, I will show you the flow in analyzing ventricular tachycardia ECG signal and normal sinus rhythm ECG signal and compare. I will explain where I take the signal to pre-processing, feature extraction and classification. Firstly, I take all the signals from CU the CU Ventricular Tachyarrhythmia Database and MIT-BIH Normal Sinus Rhythm Database. I use 60-second data from each subject and put it in Excel. Then I import the data into MATLAB, where the pre-processing done. Firstly, I use moving average filter with audio file to eliminate high frequency noise. Then I use Butterworth filter with passband from 1 Hz to 40 Hz to eliminate baseline drift and power lag interference. At the same time, there are research reports that the power spectra of normal ventricular tachycardia and ventricular fibrillation is in the range. Lastly, I segment from the 60 seconds to 10 seconds each episode, and I mark the QRS peak, and I find the RR interval and QRS complex. I tabulate all the data and the readings to Excel, where I will do feature extraction. I use mean, standard deviation, and RMS value as the feature. And this is my ventricular tachycardia ECG signal example. This is the origin signal and it is the ECG. And after I segment it, I mark the QRS peak.
These are the features I get from MATLAB: RR interval, RP, and QRS complex. Each of these features, I calculate the mean, standard deviation, and RMS. I use average function to get the mean, STD function to get the standard deviation, and SQRT function for RMS. Then I use all these features. I insert it in two types of classifier, which are the determinant analysis and support vector machine. Firstly, in SVM, I use linear kernel function, and we can see the confusion metric for the training sample. The total is 74.14%, and the confusion metric for the validation sample is 62%. And then we move on to determinant analysis. In determinant analysis, there are several tests required to test the data. Firstly, they have box test and another box test. But for the first one is chi-square and the features. The test expression is the same. HO, the within class covariance matrices are equal. HA, the within class covariance matrices are different. As the computed p-value is lower than significant level alpha 0.05, one should reject the null hypothesis HO and accept the alternative hypothesis HA. So all these tests is lower than alpha. So we can conclude that the hypothesis of HA is acceptable. The within class covariance matrices are different. Then we will see the coefficient metric for training sample. The total is 68%, and the coefficient metric for the cross-validation result is 68%. So that's all for my project. Thank you.